Cool. Thank you guys for joining me today. We're going to be talking about how to work with Docker. Basically, if you aren't familiar with Docker already, it is a container orchestration tool. It's basically a software that lets you create containers, deploy containers, manage containers, all from the command line. It's a pretty powerful piece of software. It does a ton of things that I don't think I'll be able to nearly go over or explain, but hopefully by the end of this deep dive, you'll feel comfortable enough to try and build your own container applications and just play around with the Docker CLI. So when I was trying to pull content for this presentation, I came across this comic, and it really kind of resonated to me, my own experience working with Docker. When I kind of first started, it felt extremely magical to me. I wrote a couple of lines in a text file, and all of a sudden I have this virtual computer on my machine that could do literally anything I wanted. So anyways, give you guys a minute to read it, but nothing crazy. Might be a little small, sorry. He basically discovered that instead of trying to create an application that has like these side-by-side widgets, just glued two phones together, and then he realized like this is what containers are. It's just about gluing different things together that you really don't understand. And that's really Docker in a nutshell. You don't really have to understand what is exactly happening in the container. You just have to know that you can pretty much put anything together, and that is your application. As far as like what exactly we're going to talk about, just go over some brief terminology about Docker, just to clear the air about that. Then I'll talk about how to run containers using the command line. Then we'll get into the weeds about how Dockerfiles work, how to build images, and kind of finish up with best practices when you're working with Docker. So we hear these terms all the time: Dockerfile, images, containers. I, for a long time, did not even know the difference between these things. So I try to summarize really as simple as possible what these things are. So a Docker file is just a text file that has instructions to create in a Docker image. When we talk about what an image is, it's just an executable package that contains all of the resources needed to run a container. So this can include an OS, this can include like Linux packages, this includes Python dependencies, your application code, environment variables. All of that kind of gets compressed into this Docker image that we can use for our application. And so once you have this image and you want to actually run a process on that, that is actually what a container is. So a container is just an isolated process when you execute an image. Each container, it uses its own portion of the host CPU, memory, kernel, but it is completely independent of other containers and other host processes. So unless you change that behavior yourself, you really can't communicate from container to container or container to the host application. And that kind of limitation is really what makes Docker so powerful. It lets you really deploy multiple processes on the same machine efficiently and use those resources on the host machine in an effective manner. Another important thing about the container is that every time you run an image, you are creating a new container. That container has a completely different file system, completely different set of resources than any other container that was already running or created in the past. And we'll get into a little bit more about why that is and why that's really important later on in the presentation. So we talked about containers, but how do you actually like get a container? So you can use the command line, and there's a really convenient command called docker run. It accepts a couple arguments. The main thing that you want to pass in is an image name and a tag name. So this is how you specify what image you want to execute. And then you can optionally pass a command for the container. So in this example here, I am using the Python image, and I'm looking at the 3.6 version. And so that will be my image. And the command I actually want to run is just Python, which is effectively just opening up a Python shell. So, I mean, to give you an idea, a couple more things before I show you how this works. So there's a couple flags that are included in this Docker run command that I think are pretty useful. The first thing is this -it flag. This is how you make the Docker or the container process exposed to your terminal session. So it connects your standard input to the container and emulates a terminal session when you use this flag. If you don't do this, your process will run in a completely isolated manner that you can't interact with, and it's not really useful when you're running on the local environment. So just to give you an idea, so Docker images is another command that shows you all of the Docker images you have installed on your computer. So if I don't include the IT flag, and I try and run this, and I forgot you need to include the name of your image, nothing's going to happen. So basically, it tried to run the process. It's waiting for some input. It doesn't have any connection to your terminal session, so nothing will happen. Now, if I include the IT flag, when you run locally, here I have my Python session. I can use it just like I would any other Python shell. So the IT flag is really useful for local development. I pretty much always use it when I'm running containers locally. I don't know if there's a great use case for when you don't want to include that flag, but I'm sure there might be. The other part of this command is the RM. This is more of a convenience. It's an optional flag, but every time you create a container, it's using up file space on your machine. And then you're going to have to manually remove those containers later on. It can be an easy way that you explode your file space on your computer. So including the RM flag will automatically delete your container once you're done with it. So when I exited the process here, that container is gone. So Docker PS shows you running containers. And if you want to see if you have any that are still there, there's none. So basically, the RM flag got rid of the container. If it was still there, you would see it in this command here. And sorry, I'm going to try and go through this content pretty fast, but if you have questions, please interrupt and stop me. So a big thing about Docker and that people have hesitation about is the fact that you don't have SSH. This is something that people have gotten used to when they're deploying applications and trying to debug things in another, like in a production environment. So you can't SSH in Docker, that's definitely true, but you can access a running container using the docker exec command. So what this does is basically creates a new process in that same container. And so Docker exec kind of works the same way. The only difference is instead of passing an image, you're passing a container ID. I'll show you how to get that in just a moment. And you can also pass a command. So in this case, I want to open up a shell, so I'm going to pass bash as the command for this. And you can find the container ID using Docker PS. So to give you an idea of how this would all work, let's pretend I have this Flask application that I want to deploy on a container. Literally does nothing besides just say hello. And so I'm not going to go into exactly how the image works, but you can basically, this is what the Docker image is, or the Docker file is. I'll go into details about how this Docker file works in a little bit, but I'm going to run this image, and then I'm going to basically exec into it. So if you're not sure about the name, you can always use the Docker images command. And then I'm going to, start that image. Okay, cool. So one thing I also forgot to do that is very important when you run a web process, and I'll talk about in a little bit as well, is you need to open up a port for that web process. Okay, so here is my Flask server. It's clearly running, and it's all in a separate environment. So I can't interact with this Docker process right now. It's isolated. If I wanted to, I could actually exec into it. So if I use Docker PS, I see that this image is running right now. I don't know if that's really small. This is the container ID. And so what you would do is you would pass that container ID into the Docker exec command, and then open up a shell. So here I have I'm actually inside this container. I have access to the same file system. If I go into my application code, it's all here. I could open up the file, make an edit. I mean, you can literally do whatever you want. because you have full control of the container at this point. And so you'll see that I changed the file here on my Docker or my web process. It picked up on the change. So if I wanted to reload this, you can edit the process. So you don't have SSH, but you can achieve similar behavior using Docker exec. The important thing is, though, this should not be your go-to way of debugging issues in production. Docker exec is useful if you're trying to develop locally, see your container state evolve, and have a way to access that process externally. When you're in production, first of all, you can't use Docker exec. We don't really support it for applications we deploy with YAWS. So you can't really do that. Other ways you can debug a production environment is to recreate the container image using the show Docker CLI command in YAWS. It gives you the exact commands you need to do to reproduce your container image. And you can enable logging. So those are really probably the more accurate way of debugging these issues. But just wanted to show that there is a way to access a container externally. So I'm going to just try and switch gears now and talk about how Dockerfiles actually work. When you think about development in Docker, it's kind of in a couple distinct states. So you develop your application code, and then you're ready to put it on a container. Well, you have to create a Docker file, and then you're going to build your image from that Docker file. Run your code, probably doesn't work, make some changes to your Docker file and your application, rebuild your Docker image, do this over and over again. And one of the slowest parts I think about developing in Docker is just waiting for this image to build as you keep making changes. And so we're going to talk about how to make that better. So as far as what a Docker file looks like, this is as simple as it really can get. You always start a Docker file. So each line in the Docker file is an instruction. It starts with a keyword that is specific to the Docker file language. The first instruction is always going to be a from statement. This basically means that you are loading a published image that is already available for you to download. So here I'm telling Docker, hey, I want to start with a Python-based image, and then I'm going to add stuff on top of that in future instructions. So in this Docker file, the next step I want to do is copy my application code. So this is basically the copy command allows you to copy files from your host machine into your image. So this is where you want to copy anything specific to your application that you need to run. There's also a run instruction. So this allows you to execute commands inside the image. So when you're trying to set up your application, you're probably going to have to run some commands to install dependencies. So this is the way to do that inside your image. So I have my Flask application copied over. I don't have Flask as a dependency in my image yet, so I need to run pip install Flask to make that happen. And so I was talking a little bit about the networking issue with container processes. So when you run a container, it is completely isolated. It has its own set of ports that are not immediately exposed to the host machine or externally for that matter. When you have a web application, you need to be able to accept communication. So if you're running your web application in a container, you need to be able to open or publish that port to the host machine. And the way you do that is by using this expose command. So the expose command accepts a port as an argument, and this really is a signal to the user that, hey, I need to deploy this application, so in order to do that, I'm going to have to open up port 8000. By itself, this is a little tricky. Expose does not do anything. I think Jesse and I have learned this when we were working on, I want to say, statsd image. But yeah, so just including expose 8000 is not going to do anything. You have to actually, at runtime, include this -p, which is a flag to say you're trying to publish a port, and then you give it a host port to map to the container port 8000. So in this case, I'm saying, let me treat my host port 8000 and forward all of those requests to the container port 8000. And this way, I'm able to access my web server over that same port. The last part of this Docker file is this command line. So typically, you want to include a command instruction. This is basically telling a user that if you don't specify a command when you run your image and create a container, this is what's going to be used. So in my example here, I did not specify a command after my image. So what I was doing is actually running this Python app init.py. Any questions so far?
exposed, like you don't have to put that in, right? If you run it with the thing, so that's more of just like information for someone reading this.
Yeah, so it really doesn't matter if you include this line or not, but it is very helpful if you're publishing images for someone else using it to know, hey, this is going to respond on port 8000.
Because that 8000 has to match what's in its app file. But yes, this is just documentation.
So that you know when you run it, that's the port you're supposed to.
Yeah, I think that's why it's a convention, but it doesn't actually do anything, which
There's one thing that it does, which is not a good practice, but it can say, open up, all the ports are exposed, and don't even care about them. So you can do that, but people don't. But if you use a dash P the lowercase, we can use the dash P uppercase, and that means open up all of them that were exposed, which we don't do. So if you look at the odds, like it says, what is the port that I should be mapping? Because we need a port for web still.
Cool. Anyone else?
How does it pip install? Like, how does it talk to the internet? Does it just take like your own network settings or whatever, so it can pip install stuff?
Yeah, that's a good question. I believe it has the ability to access things externally. It's just inbound requests you have to manage yourself.
this you're building from, like right now it's instructions, you take those instructions and you build an image and you do that from all sorts of places. You are not inside the executable package that you are building like that.
I'm not sure about building images, but when you run them, you can say that there's a different network. I don't know what the name is, but basically, if I'm not wrong, by default, it inherits the network from the host you run containers. But you can say, I want to use a different networking cover supports.
But this pip install only happens when building, not when running.
Yes.
Or
So I don't think it's not like a copy tab.
sure. Yeah, this might make a little bit more sense if you. So that example here is pretty much what this first Docker file is. I did a little bit of a different step where I had a requirements file, but you still have this copy app. So what it's looking for is looking for this app directory up here. It might be a little hard to see. That has all of my application code, and I want to copy that into my image. So that's what the copy step is doing, is it's taking files from your host system into your image.
So like this only that copy command is only ever run like when you're building the image.
Right. Sorry, Annie. Yeah, so I had a requirements file here. In the example, I didn't want to include that just to be a little more simple, but it does the same thing. Yeah, I believe we copied the entire directory in our global Docker file. So we copied requirements, your application code, all of that stuff.
But we do assume that we do a similar run to install requirements. So like if you decided you wanted to name this something else.
So there's no difference between like adding to
Oh, yeah.
file or modifying the file. We'll end up doing
So yeah, just
better to put it in your requirements file because we should do all sorts of things. But yes.
like for something we were adding like to the Docker file and
I think that people were doing that because that way you didn't end up getting it on your regular applications, which is only Python 2 code. So that was a way to like skip around it.
yeah. So as far as like our YipitMake file, we're copying the entire directory here. So your entire repository into this app directory, and then we're pip installing it through requirements file. So yeah, it does expect that file. Cool. So we have this Docker file all ready to go. We want to build it. How do we go about building it? There's a command in the command line for this called Docker build. It expects a few arguments. So the main argument is a path. So in this YipitMake file, we passed in this dot. I guess so. Like basically, you're saying, I guess this is in the build phase. Let me think about another example. you're basically saying like from my host machine, what is the directory to go to find your Docker file and any of the related files to build. So by default, it is looking for a file called Dockerfiles. So if you ever notice in your repositories, that's why it's called Dockerfile and nothing else. You can optionally name your Dockerfile something else and still build the image, but that is the default behavior. I think the important thing is when you build your Docker image, you want to tag it with a name. This way you can actually associate what it is doing in the future when you want to run it. So that is this name argument up here. The other thing you want to do is the tag. Basically, you want to give a version for your image as well. So if you looked at my images here, I have so this repository is that name field, and this tag is the different versions I have for each one of these images. So it is really important to try and version as much as possible so that you have kind of a history of the changes you're making to your Docker image. That way you can easily revert back to an older version of the image if you ever made a mistake during your development process. It also lets you leverage some of the other tools in the development process that Docker provides, like caching. If you can overwrite tags, but it's really bad practice, and it can cause a lot of problems. Like let's say you overwrite your tag and pushed it into production. Well, all of a sudden you're using an older version of your image and you had no idea that it changed. So we've seen this happen with like the Python image. So the base Python image in Docker Hub does change over time and updates into newer versions of Python automatically. And that can be an issue if you're not prepared for those changes. So you should keep that in mind and try and keep your naming and tagging as constant as possible.
Jesse is living
But I've gotten 3 emails saying, I think we should name it Python.
So we keep talking about this image as kind of this nebulous concept. I guess the closest way to really think about it is it's a series of layers. I was reading about this a little bit earlier today, but basically Docker's file system is based on layers where each layer is kind of an independent change to that file system, a change to that image state. So every time you create an instruction in your Docker file, you are creating a layer for your image. And so when you build your image, you're basically creating a series of these layers that are immutable. So you're not supposed, as a container is running, it cannot edit these layers below it. However, the key difference is when you run an image and you create a container, you are basically creating a thin layer on top of your image that is editable. And so while your container is running, it is basically making changes to that specific layer. And that's kind of how you can have one image on your host machine, but multiple containers running independently and in parallel, because they all have their own editable layer, and they have a bunch of immutable layers below it, which represent the image. I thought it was a really cool concept. Personally, I don't really understand how the layers work, other than I know that they exist. So when you download an image from Docker Hub, for example, you're basically downloading all of the layers of that image separately. And then Docker knows how to use them in conjunction when you're running your container. Another thing that was interesting is basically only from, run, and copy create layers. This is an optimization that Docker made a few versions ago to basically reduce the number of layers in your image. And so it kind of makes sense because these commands actually change the image state versus something like expose, which really doesn't do anything. So I thought that was also really cool and surprising. So now that you kind of have an idea of how the Docker files work, there are definitely good ways to write Docker files and bad ways to write them. I think from my understanding, the best Docker files are ones that in the documentation, they use a term called ephemeral. And basically that means that the image is created in such a way that you can provision containers very easily. You can create containers, destroy containers, and any setup that is needed for your application is handled inside that image. You shouldn't want to be in a situation where you create your Docker process and then feel like you have to go in manually and set something up on that container. If you're doing that, you're probably doing something wrong in your image. So I'd say like that's probably your bare minimum requirement for a good Docker file is just to handle all of that setup code. But what makes Docker files better versus other ones, as you should try and minimize the amount of layers you have in your Docker file. The more layers you have, it leads to a larger image size and a longer build time because you're, once again, kind of having to create each one of those layers separately. And then as you're deploying them, you're going to have to, in your production environment, download each one of those layers. The other thing that is kind of interesting is you want to order the instructions in your Docker file so that you take advantage of what's called a build cache. So every time you are building an image from your Docker file, it's going to look and see if you have an image of the same name previously and try and cache whatever layers have not changed. So this kind of means that you should structure your Docker file in a smart manner where you have the least likely to change instructions going to the top of your Docker file and as well as like the longest running instructions. So if you ever look at like published Docker files, you'll see that at the top is almost always things like installing OS packages, updating Linux, and at the bottom is more application-specific code where you are executing some shell command specific to your application that you know is likely to change over the course of time. Just to give you an idea of what this caching looks like. So I have this image right now, this Docker file. So if I build the same Docker file again, it will use the image cache or the build cache, and it will run like pretty quickly. So there's a Docker build. I gave it a new tag, and then I'm pointing it to the same directory that I'm in. Well, that was unexpected. Yeah, good catch. Yeah, so as I was saying, if you don't have a Docker file, you can pass this -f flag to say, I want to actually look for this specific Docker file. So it's not conventional. So you see that some of this stuff was cached. I think I've edited this Docker file since I ran this demo. So you can see that here I was using the cache. Everything until the pip install was basically cached. And so after you break in the cache, all the future steps will run. So if I do this again, you'll see that I use the cache for every single step of the process. Yeah, the cache is obviously much faster, but with any time you have caching, you should just be careful. Sometimes the cache can get invalid and you can run into weird scenarios. So other things about making your Docker file really effective. Use the right base image. This is probably the most important thing you can do for your Docker file. Using the wrong base image, you will probably install a bunch of stuff you do not need. Even if you look at just like the Python Docker image, it has about 700 megabytes out of the box, and the slim Python image only has like 150 megabytes. And really functionally, there isn't a difference for the most part. If you need to install something, you can always install that in your Docker file, and you're probably better off explicitly including those as dependencies for your container application. The other thing, as I was discussing earlier, use a versioned base image. If you don't include a version, you'll always pull the latest, and that can be really unstable because new versions can come out at any given time, and any future containers or images you build could break down because of that. Another kind of technique you will see in Docker files is combining layers as much as possible. So you may find yourself in a position where you want to install a bunch of Linux packages. So in this example, I have, I want to update my Linux package manager, and then I want to install Vim, cron, and some logging tools. So this seems fine, and it will work when you build your Docker image. But for whatever reason, you have 4 layers when you could do this all in one layer and be really efficient with it. So you'll see a common practice is to use this $& operator to chain a bunch of shell commands together. So in this case, you can basically do these 2 layers in one layer or any number of layers. And so it kind of looks a little gross, and but actually that's really the right way to go about it. If you look at like the Python image, you'll see like 20 of these OS packages all chained together using this ampersand. That's just bash syntax. If you aren't aware with what the ampersand does, it basically means that it's going to run what's left of the ampersand first. If it's successful, you're going to proceed and execute what's right of it. And so that's kind of how you sequence these executions in order. Another thing that's really important for Dockerfiles is you should only install what you need. Linux by default will install a bunch of recommended packages it thinks are nice to have, but you probably don't need. And when you're kind of trying to minimize your image size, it's not the best approach. So you can disable this behavior by passing this no install recommends. You'll see this as well in a lot of published Docker images as just a way to get around that default behavior. And then kind of like the last really key thing about keeping your Docker file clean and small is deleting temporary files after you install them. So a lot of the times when you install packages, there's going to be a lot of random files kind of floating around in your Docker image. You should just go and clean that up in your image itself. Like in this example, let's say you're downloading a Debian package from S3. You go and install that package, and then you want to remove that package after it's installed. The same applies to like apt installations as well. So yeah, to give you an idea of what that looks all together, so I had this Docker file in kind of not optimal shape, bunch of commands I'm installing. You can kind of concatenate all of that together into this one line here. Looks a little gross, but actually it's better for Docker and image building purposes. And as far as like what the final outcome is, you can see pretty large reductions in image size. So I was using a really small image to begin with. And so in this example, you know, if I did this Dockerfile 2, which was not really optimized, it went to 260 megabytes. But cleaning it up and using the techniques I just mentioned took it back down to 200 megabytes. So this is, like I said, a contrived example. In production, the images we probably use are really poorly optimized, and I've already been doing this with the Airflow Docker image, and I've seen, you know, at least 60% of the file size was wasted. And I had like a 1.4 gigabyte image, so I went down to like 600 using just those kind of 3 techniques. So regardless, you can kind of imagine this is pretty inconvenient, having to change your application, build a new image, and keep doing that over and over again. So the last, there is a concept, sorry, I jump around a lot. The last concept I want to explain is volumes as far as optimizing your development process. Volumes are a way you can host or mount a file system outside of your container to inside the container. This is really useful because you can continue to modify these files and your container will be up to date. So you can imagine if you're building out like a web application, you're going to be changing a bunch of things. You want to refresh your page, see if it works. You don't want to have to build an image every time you make a change to your application. This is a really easy way to get around that. I'll kind of give you a demo of how that works. So I wrote this command out ahead of time because it is kind of ugly. So what I'm kind of doing here is doing the same thing as before, Docker run, pass in rm, it, map my port, and then add this -v command. So this -v is how you signify a volume. And what I am doing is I am mapping my application folder, that is this folder right here, to my container process. Probably passing wrong. Okay, so now show you that it is, my web server is running. It is running an isolated process, but it is connected to this file system that is on my computer, my host machine right now. So if I change this, it's going to pick up that, hey, there is a change in my Flask server. If I go back and reload, it is there. So as far as development, it makes life a lot easier if you use volumes, especially for something like front-end development. But you shouldn't rely on it for production. It's kind of an anti-pattern, as you want your container processes to be as isolated as possible. So there are use cases for volumes. In general, how we deploy, we don't really use them, but I do find it as a useful technique for local development. And so yeah, just as I had shown before, you use the -v flag, you give it a path on your host file system of what you want to mount to a container path. So I basically mapped my app directory to an app directory on my container. So there is, one more thing I want to say, there is a volume instruction for your Docker file, but it isn't necessary. Like expose, it doesn't really do anything. It's more of just a signal to a user that you want to mount a file system. So even if you had something like here where you're still copying an app directory over and then mounting a volume on top of it, it's still going to keep track of your changes. So yeah, it's pretty flexible in that manner. So a couple more things about setting up your Dockerfile. Once you have your packages installed, your application code ported over, you probably want some environment variables. There's two ways to do this in Dockerfile. There's an arg and an env instruction. So arg is a build time variable. It lets you define an environment variable that is only in scope during the build phase. This is a really useful technique for when you want to use secrets, when you're installing stuff or any kind of credential management, because it will only be there when you build the image, and once you're running your container, it doesn't have access to those variables. So something like local shop, which is actually how we use local shop when we're building containers, is a good candidate for the arg. Env is just like a normal environment variable. It sets something in scope in the build phase and after when the container is running. You can also pass them in the CLI. There are different flags. So this --s build arg is how you pass in build arguments, and then -e is how you pass in environment variables. So if you pass things in through the command line, it will override whatever you set in the Docker file. Just something to keep in mind. The final part about a Docker file we talked about was that command line. So you will want to end your Docker file with either a command and or an entry point, which we haven't talked about yet. If you don't define these explicitly, you're going to inherit the command or entry point from your base image. So that can be tricky because sometimes your base image will have an entry point. And I guess I should explain what an entry point is first. So an entry point is kind of, as it sounds, a starting point for when you run your container. So it will execute some code automatically at runtime for when you create a container. That code is always executed, whereas a command is more of an optional kind of thing. If you don't explicitly specify a command, it will run whatever's defined in your Docker file. But an entry point will always be executed. And this can be really tricky because your base image can have an entry point, and if you're not aware of that, if you try and run a command that doesn't account for that entry point, you can run into issues. So it's good to be explicit about these. There are use cases for entry points. Sometimes you want to install background processes or services when you start your container. That can be a good use case for an entry point. If you need to wrap additional context around your commands when they are running, that's also a good way to do it. So any kind of complex startup scenario for when you want to launch your container process, if you can't really fit it into like 1 or 2 arguments, you should probably just put it into an entry point. And so what that kind of looks like. So in this Docker file, doing the same stuff as before, copying our Flask application, installing some requirements, opening a port, and then I've included this entry point here. So what happens is I'm telling it to, when you start my container, run this bash script, this app/setup.sh. So this bash script, in this example, it's just printing some stuff out. And then as an example, I'm starting cron when I start my container. And then a key thing about how the command and the entry point interact with each other is that your command gets passed to the entry point as an argument. So if you don't, the default behavior for this image will be to run bash/setup.sh, and then Python appinit.py are passed as arguments into that bash script. So this is just some syntactical sugar to run those commands. but it's really up to you to manage how the command is executed from the entry point if you choose to use it, which which can be really tricky to debug if you're not aware that your base image has an entry point. So to give you an idea of what that looks like, so you can see kind of in the output, right before I started my Flask server, I printed out the statement. I created and started our cron process, and then I served my Flask server. Now, if you don't want to launch your web process, even if you specify you want to do something else, you're still going to hit your entry point. So you see that I still printed out my statement, I started cron, and then I opened my Python shell. So like I said, entry point is always run. Just be aware of that when you're working with them. So yeah, covered a lot of context really fast, and I hate to break it to you, but that's really the tip of the iceberg. There is so much stuff to talk about when it comes to Docker. It's a very large and popular platform. As far as how to get started with it, for me, I found the documentation was actually pretty well written. It covered a lot of really complex concepts without going too much into the technical details. The other thing I found really helpful is actually reading the Docker files for base images. So if you're using something for a project like Python, go read the Python base image and see what it does. The Dockerfile syntax is not too complicated. It's really just a bunch of shell commands at the end of the day. And they're usually on GitHub. And then lastly, of course, just go out and build some images, try it out, see what works, what doesn't. It's a pretty hands-on process, and that's kind of what makes it fun. At the end of the day, it is a steep learning curve, but it does pay off. Containers are really nice once you get them working because it makes your local development and your production environment in sync. The image you build locally is what you're deploying in production, and it's much easier to reproduce bugs as you have them. It also increases, I think, which is kind of cool, the flexibility in your application. You can manage OS packages much easier locally. You don't have to worry about brew installing something or worry about how Chef is deploying a package. And your Python versioning is really simplified. Switching from Python 2 to 3 is just changing the base image. And assuming your code can handle it, you have a different version of Python for your application. You don't have to worry about virtual environment and making that work. So it's more stable, it's a little bit more flexible. It's definitely a really nice way to architect our infrastructure. And that's it. So covered a lot of concept. I'm kind of surprised there aren't more questions. Are there questions?
Is there any reason you would not want to cache when you Docker like parts of our Docker?
It can get tricky if you are copying files over and then you're running commands based on what you've copied over, because your cache can get into a weird sync. I haven't run into an issue where the cache has become invalid, but Docker doesn't know about it. So far, for me, it has been pretty robust, but I don't know if you guys have encountered a scenario where the caching has failed you.
So if we decide there's a lot of Docker, there's actually a parameter to avoid the cache. Because if you remember Anup's presentation, it was like apt-get update, apt-get install this and that. Well, if you cache that apt-get update 2 days ago, download some versions, let's say Chrome 65, it would download 67 today, but you don't know it because it's cached. So some people are against that idea because you never know. It becomes non-deterministic instead of deterministic. Like if I run it now, I know exactly what I'm getting. Like if he runs it, he gets something on his machine. If I run it, I get something on my machine. And that's not great because we run at the same time, the same day. There's one who was going to mention about caches. Oh yeah, our build. Because we build things in Travis, it's a pan run. Travis deletes the container as soon as it finishes, or the virtual machine as soon as it finishes. So there is cache, but only does it once. So it's the same thing as not having cache.
Did we have a cache when we were building that? Yes, right?
Yes.
Right. So on build up, we had the option for this problem, the food game, all at once.
Yeah, but it's very nice for local developers, as I've said. Because
Yeah.
when you're on your computer doing like 10 builds an hour, that makes a big difference.
Yeah, I have my off here just I'm building an image, so that it takes a long time.
Yeah, it's a problem.
So why does virtual environment exist then for stuff like Python? Like why?
I mean, every time if you're going to have a Docker image, then you're going to have to manage that container process. Virtual environment at least preserves state, so you can come back to it after time. Whereas if you leave your container and delete it, it's gone. So it's good in one aspect, but for typical types of development, you probably want to use virtual environment.